Today we're going to be looking at the angle addition postulate. Here's the big idea of the angle addition postulate. It says that we can take angle CAB plus BAD, and that'll equal the whole large angle CAD. So like what we were talking about in class the other day with segment addition, we're doing with angle addition. So the little angle plus the little angle will equal the big angle. Okay, or I labeled it with numbers instead. So angle 1 plus angle 2 will equal the large overall angle, angle CAD. So here's our first example. We want to find the measure of angle ABD. So remember reading our angles. B is my vertex. Okay, so ABD is really this large angle right here. So the angle addition postulate says I can take the two small angles and add them together to equal the large angle. So 22 plus 39 will equal the measure of angle ABD. So if I add that together, I get 61 degrees. My next example says if the measure of angle ABD is 121 degrees. So let's find ABD first. So A to B to D. So we're talking about the large angle here is 121. I'm going to go ahead and draw that in here. This is 121. We want to solve for the value of x. So remember, the little angle plus the little angle will equal the big overall angle. So I have 4x plus 2 plus 3x minus 7. That's my little plus my little will equal the large angle, which is 121. So I'm going to combine my like terms. 7x minus 5 equals 121. Next, I can add 5 to both sides. So I have 7x equals 126. When I divide both sides by 7, I get x equals 18. The next example says if the measure of angle ADC is 77 degrees. So again, let's look at ADC is the large angle, ADC. So this large angle here is 77 degrees. I want to solve this time for the measure of angle ADB. So when I'm all done, this is the angle that I want to solve for. So we're going to start the same way. Okay, so I need to start by solving for x. So my little angle plus my little angle will equal the large angle. So x plus 7 is my first little angle. My second little angle is 2x plus 19. That should add up to be my large angle of 77. So let's combine our like terms. So I have 3x plus 26 equals 77. I can now subtract 26 from both sides. So I have 3x equals 51. When I divide by 3, I get x equals 17. Okay, but we're not done yet. Remember, we're solving for angle ADB. We know, according to our figure, the measure of angle ADB is equal to x plus 7, right up here. So I now know what x is, so I want to plug it in for x up here. So I really have 17 plus 7, which is equal to 24 degrees. So the measure of angle ADB equals 24 degrees. The next big idea is the angle bisector. So if you remember, a segment bisector or a midpoint cut that segment in half. Well, an angle bisector cuts our angle in half. So you'll notice here we have tick marks. We have little arcs with tick marks on them to show that the angles have the same measure. So in our case here, angle AOP is equal to the measure of angle POB. All right, so in this case, it says MO is an angle bisector. So we can see here that we have congruent angles, right? This time they marked them with double arcs, but these two angles here are congruent. I want to solve for the value of x. So now, if my angles are congruent, that means they have the same measure. Okay, so if this bottom angle here is 23 degrees, then this angle here must also be 23 degrees. That's what the angle bisector does. So we can set it up to say our expression 4x minus 5 has to be equal to 23. So 4x minus 5 equals 23 degrees. I'm going to add 5 to both sides. So I get 4 equals 28. 4x equals 28. Divide by 4, I get x equals 7. For this next problem, it says RQ is an angle bisector. We want to solve for the measure of angle PRQ. So I want to solve for this angle right here when I'm all done. So now remember, the key here is that this is an angle bisector, which means my two angles, which are marked here in red, are congruent. So if they're congruent, that means they have equal measure. So I need to put an equal sign between their expressions. So x plus 40 has to equal 3x minus 20. Okay, so now we can solve our equation. I'm going to subtract 3x from both sides. So I have negative 2x plus 40 equals negative 20. Now I can subtract 40 from both sides. So negative 2x equals negative 60. I want to divide by a negative 2. So x equals 30. Okay, now we're not done. We know what x is equal to, right? But we want to know the measure of PQR. So the measure of angle PRQ, I said that wrong. PRQ, according to our figure, is x plus 40. Well, we now know what x equals, so let's plug it in. So the measure of angle PRQ is equal to, instead of 30, we're going to plug in 30. So we have 30 plus 40, which is 70 degrees. So the measure of angle PRQ equals 70 degrees. For our final example, we can see here that we have an angle bisector again. Our job is to solve for x. I can see my angle bisector here because of my congruent tick marks. Okay, but what I'm noticing is I'm missing an expression here. I have nothing for this angle. I can see my whole overall angle is 150 degrees. And I can see this little bit here is 4x minus 5. So keep in mind, because these two angles are congruent, I should be able to use my 4x minus 5 up here as well. So I'm going to go ahead and write in 4x minus 5. And I can only do that again because my two angles are congruent. All right, so now we're looking at a little angle plus a little angle equals a big angle again. So I have 4x minus 5 plus another little angle of 4x minus 5. That should equal 150 degrees. So let's first combine our like terms. So I have 4x plus 4x gives me 8x. Negative 5 plus a negative 5 gives me a negative 10. That equals 150. Now I can add 10 to both sides. So I have 8x equals 160. If I divide by 8, I get x equals 20.